My favorite of the convergence tests is the p-series test. So the p-series test happens when you have a summation and it's 1 over n raised to some exponent. So p is the exponent. So we're going to be looking about when that p changes, it's going to decide whether it converges or diverges. So it says if p equals 2, then the series. So when I've got something where it's like 1 over n and that exponent is a 2, we proved earlier that that's going to converge. Or what we talked about earlier, and this test is going to tell you why, and then we'll prove it later too. Versus if p is 1, so 1 over n, and then the exponent is a 1, that's the harmonic series, that's the same thing as 1 over n, and that series is always going to diverge. So this one's getting smaller fast enough, this one's not getting smaller fast enough, so it's going to diverge. So this is true for all exponents. We could test some more, and in class we normally would, but since we're just summing it up on a video, in general, a p-series is going to diverge if the p-value is less than or equal to 1. So here, our p was 1, so it diverges. If it was 1 over n to the 1/4, that would be a number less than 1, that's going to diverge. Our p-series is going to converge if p is greater than 1. So here, like n squared, that's going to get smaller fast enough. It was 1 over n to the 8th. That would also be in p that's bigger than 1, so it's also going to converge. So examples, here we've got 1 over n to the 4th, so 4 is greater than 1, so this example is going to converge. Versus here we have 1 over n to the -3, that's less than 1, so that's going to diverge. And that's really all there is to the p-series test.